Today lesson we learn the wood and masonry construction, and we have three learning objectives. Explain the typical practices in wood and masonry construction. We estimate the necessary quantities for wood and masonry structures and determine the safe vertical reactions at the end notchings of the wooden beams when we need to have notching the beams, and the safe unbraced height of the fresh masonry walls to withstand the winds. And that are the learning objectives we have. So let's go to the briefly overview the first video, which is the wood construction. So for wood construction, as you can see, it have multiple application. Just give you a typical wood structure. It can be put in the floor. It can be for the stud, the column. It can be for the truss in the roof, and the use for the sheathing. So all of that have good components in the structure, especially residential construction. This is show you one of the gold framing with stud and for load bearing, and how the wood apply. And you can see that if for stud, it can be the used for floor joint, and it can use for blocking to reduce the effective length of the stud so that it can sustain more compressive force for the stud. So all of that can use the wood structure in here. And of course, as you can see, the wood have a limited length, so connector are also necessary, and normally they use steel, other metal components. So in this slide, it show you different timber connectors that we can see in construction. And of course, same for connector, they also use shear plate or split pin, as you can see here, to connect between the members of the wood or timber, and also truss plate to connect between the members. You see for the truss in the roof to maintain the structure work at the joint between when all the member of the wood join together to make a joint. And that you learn for the truss member, how that consider a truss member, two force member, etc. So that is the truss plate to connect between the joint. And of course, the design for the area with the strong wind, like in our area, Florida, and other areas, may be different requirement for the truss plate, as you can see there. For the column, when connecting, depends on the way that column work. The connection are not the same, as you can see. If just only the column work at the central loaded to the column, then you can use the dowel to connect between the two components, two timber or wood components, make the column for that whole column. But if we have moment, share the connection for the column in the wood, it can be more sophisticated. As you can see here, use strap, bolt, and washer, and then wood supply plate, all of that to improve the withstand to moment or shear at that point, compared to the lower connection when it tend to be sustain only the central loaded for the column in there. And for the how the typical column like timber connect to the base, as you can see, there also depends on the way that it work. There are multiple ways that you have. This is a simplest form when it less moment components in it. But then when we have shear and moment at the column to base connection, then the connection it tend to be more complicated in there. And it also depends on where connected to, which material they connect to. For example, here foundation, as you can see, it concrete. Sometimes they put the U-strap into the concrete, place the concrete, and then connect the wood column into that U-strap with the base plate, pier, etc. How about the beam and two column connections? And it can be continuous, as you can see, or single support beam that I will go into show in the next slides. So this is the continuous beam. This is a column, and in this column it can be a wood or it can be a pipe column made of steel or other metal products. So you can see the way that they connect. There are multiple ways to connect between the continuous beam and the columns, and that column it can be made also from timber or some other type of materials, as you can see in this figure. So this slide give you an overview, different practices used for connection and application of wood in construction. And then, as I say, the simple beam, it means non-continuous beam. How that connect to column? This is one end, so you can have that kind of connections. If we have a beam and then connect to the column, and then another beam connect to the column, the way it work also different. And then the last one, and you can see two beams on top of the columns. So the also non-continuous beam stop at the column. It connections also be able to, and that apply with the T plate, as you can see there. So multiple way to connect the beam, and normally it's designed by the licensed engineers. And also beams, timber beams also connect to the masonry go, and how that work. If it go parallel to the go, so you can give the anchor bolt, as you can see here, or perpendicular to the go, then it can have the anchor bolt in the masonry go, and then you can use the bolt to connect that to the beam. And it also other way with the roof beam connect to the masonry go, as you can see in the below picture here. So bottom line, there are multiple ways that we can use to connect the wood structure to the columns, to the wall. And of course, it also depends on the material we use, and especially the way how the load work, how the beam work, how the other components work, whether it's stand for the moment, for only central loaded components, or other type of forces that structure have to be carried, and that you, when you study steel design or concrete design class, you know better than that in there. And for the intermediate beam support, as you can see, the beam, the wood is long, it can have buckling, and that something intermediate beam can reduce the effective length so that it can get a better load. And in this case, as you can see, the main beam is long, then and then we can put the purlin, and the purlin, of course, for the roof, you can put the roof on that, or just the other way that you can put the intermediate beam support to reduce the effective length for the main beams, that you can see in the other fingers shown on the right. And also timber termite, as you can see, one of the issues, and these are the few practices to show how to make a shield so that we can, especially when the wood interface with the foundation, the ground, and that tend to be more termite, how to do that. These are the way that you do. And also is the when you connect the beam, sometimes we need to notching it, notching. So the DE, which is the effective depth or height of the beam, are not the actual depth of the beam anymore, because you are already notching, and that come up with what is basically the maximum vertical load that the beam can withstand. And you can see before notching it much more, after notching, how that affected. And in the note of today's lesson for the wood, as you can see note here, we show you how to determine that vertical reaction that considered safe for the end notching beam, and that equation in your book is RV equal to 2FV B dE square over 3D. What is RV? The safe vertical and reaction. So when you have the reaction there, if you put the load too much on there, if it exceeds that load, the beam can have a local break in this area, and of course when it local break, the whole structure will be collapsed. What is FV, the allowable shear stress? If we go to the final exam reference, and if you go to page number 4, of course we will talk about this more when we study formwork design with the timber later on in this class. And if you go to page number 4, you can see with allowable shear stress, which is the third column here, FV. Of course, we will talk about that later on in the next few weeks. And you can see here with different type of wood, Douglas fir, hemlock, southern pine, California redwood, aspen spruce. The FV are not the same, and it measured by pound per square inch if we use a foot pound system. For example, if we talk about southern pine, 180 pound per square inch. In SI unit, it will be 1241 kilopascal, as you can see there. So that is the allowable shear stress for, and it depends on different type of wood that we use. So that for the FV we are talking about. B is the width of the beam, so the depth of the beam, that is the width of the beam. The other side, if we have a cross section, the depth of the beam or the height of the beam, D, and it should measure with the actual depth. And you can see for, let's go to the reference again, final exam reference. If you go to page, go down further to page 7, start at page 7 here, and you see if you go to Lowe or Home Depot, when you say, okay, I want to buy the 2x4 for the size, for example, and that is the nominal size, that cross section. 2 stand for the width of the width, okay, and then 4 inches stand for the height or the depth of the beam, width and the depth of the beam, and that is the nominal size in inches. The actual size, as you can see there, is actually the actual size for the width, only 1.5 inches, and the actual depth or the height of the cross section of that wood structure, if 2x4, only 3.5. So that is actual size. So when you design, you need to consider the actual size, not the nominal size when you determine. So keep that in mind when we do the wood structure, and of course any other structure, we need to focus on the actual size. The depth of the beam, and then the depth of the beam above the notch after you cut. So this is actually what is left over after you notch, and that matter in here. There are scenarios when you have the notch is curved, as you see in the left finger in here, curve, and the distance of the curve is more than the DE, the depth of the beam above notch, as you can see there. Then the equation above RV is much simpler, 2FV BDE over 3. Or you can bevel, which is the right finger in there. So you see the DE and the bevel distance is more than DE. We can apply this equation. So simpler than the equation we discussed earlier. So that is the overview, the wood construction with different connectors, different application of the wood in construction. In the next video, you will learn how to determine the quantity with the practice you, for example, board feet. What is that about? Exposed to that unit. Hopefully you heard that before, but otherwise you can see that problem 1. And problem 2, we will determine the RV, which is the safe vertical reaction if we notch. And from that, we can move on to the second topic of today, class E, masonry construction.